India has done the impossible. They have achieved a historic milestone, becoming the first nation to land a spacecraft near the moon's south pole. The mission was known as Chandrayaan 3, and what it saw on the moon was shocking. India lied. The goal of this mission was to show India's cutting-edge technology while trying to find water ice on the South Pole at the same time. But why water? Why the South Pole? And did it even find any? Join us as we explore India's monumental Chandrayaan 3 mission and see what secrets of the moon they uncovered. The journey. It all started on July 14th, 2023. That's when the Chandrayaan 3 mission started. Chandrayaan 3 launched from Sriharikota in southern India. Chandrayaan 3 isn't as fast as NASA's Apollo missions in the 1960s and 70s. It took longer for this craft to reach the moon. This is because India used less powerful rockets. To make up for it, they decided to make the rover orbit Earth a few times to gain enough speed before breaking off and heading toward the moon. That's why it took a month for it to reach lunar orbit. On August 5, it reached lunar orbit.
Sun has set again in between Israel.
On August 17, the Vikram lander module decoupled from the rest of the ship. It then descended towards the moon. All of India was watching closely. Everyone was gathered together with their eyes glued to their television screens. The suspense was palpable. The moon's south pole could hold water ice and valuable elements. They just needed to land there safely. As they got closer and closer, the anticipation only increased. The outcome was far from certain. Inside Vikram was a small rover called Pragyan, which means wisdom in Sanskrit. If it crashed, they'd lose both the lander and the rover. It would be millions of dollars down the drain. Temples and mosques hosted special prayers for a safe landing. Along the banks of the river Ganges in Varanasi, Hindu monks bestowed blessings upon the mission and blew conch shells. Tension peaked during the lander's final moments as Vikram initiated a complex maneuver. It deftly decelerated from an astonishing speed of 3,730 miles per hour to nearly zero, all while transitioning from a horizontal to a vertical orientation. This was the crucial moment. The lander needed just the right amount of tilt and thrust. Too much, and it could tip over. Too little, and it might hit the moon's surface at the wrong spot. In 2019, India's last moon mission faced a problem in these final minutes. The lander couldn't change its position and crashed during landing. So they had learned their lesson, and it was at this moment they had to apply their knowledge or risk failure once again. But on August 23rd, there was a different story. The entire country was silent as they anxiously waited for the landing to be over. And it was a success. The Indian Space Research Organization, ISRO, confirmed that Chandrayaan 3's lander had made a successful landing in the moon's southern polar region.
India is now on the moon.
ISRO released a 2-minute video showing how the Vikram lander descended, hovered, looked for a safe landing spot, and finally touched down. Celebrations erupted across the country and even beyond. The European Space Agency supported the Chandrayaan 3 mission, strengthening the relationship between ESA and ISRO. Its Director of Operations at ESA's ESOC Mission Operations Center, Rolf Densing, gave his congratulations on ISRO's historic landing. As the Vikram lander touched down near the little-explored lunar South Pole, Sridhara Panicking Somanath, the chair of ISRO, exclaimed that India was on the moon. For her, this achievement wasn't just the work of ISRO, but the result of efforts by a generation of scientists. This success solidifies India's position as a space power. The Indian government aims to boost investment in private space launches and satellite-based businesses. It's a momentous step forward in India's space journey, opening up new possibilities for exploration and discovery. The Indian Prime Minister, Narendra Modi, celebrated this historic victory as he watched the moon landing in South Africa. He said that it's a victory cry for India, and they have reached a place no other country in the world has before. Street parties erupted across India, marking the momentous achievement of landing on the moon's south pole, a first for any country. India's flag waved high, representing the nation's pride and progress. This triumph followed Russia's recent moon mission failure, where their Luna 25 spacecraft lost control and crashed. The head of Russia's space agency attributed this setback to a lack of expertise due to a long hiatus in lunar research after their last mission in 1976. The US, the former Soviet Union, and China have already achieved moon landings. But those were near the moon's equator, not in the challenging South Pole region. The difficulty of landing in this area became evident with Russia's mishap. Japan's private space startup, iSpace, also attempted a lunar landing in April 2023, which resulted in failure. The South Pole is very difficult to land on. This is because of its uneven surface, filled with craters and boulders. Chandrayaan 3's success was a major leap, arriving 15 years after India's first moon mission in 2008. That mission, Chandrayaan 1, made groundbreaking discoveries about water molecules on the lunar surface and the moon's daytime atmosphere. India's second lunar attempt in 2019 was less fortunate. While the orbiter survived, the lander and rover were lost. Chandrayaan 2 had its setback with a missed soft landing, but its orbiter continued its mission. And it's even helping the Vikram lander provide data and photos back to Earth. India has learned from past challenges with Chandrayaan 3. Landing near the moon's south pole presents challenges due to rough terrain. ISRO has made adjustments for a smoother landing. The lander now has a broader potential landing zone, extra fuel, and more robust legs for impact. Chandrayaan 3 builds on previous lunar missions and promises substantial scientific discoveries. But India isn't alone in its lunar ambitions, with other countries also exploring the moon, as it's considered a gateway to deep space. Russia's recent setback and China's ambitious plans have heightened interest in India's mission. China aims to send astronauts to the moon within the decade after launching a crew to its orbiting space station. And with India's landing on the South Pole, global eyes are all over the moon. But this mission doesn't only have global significance, it's also very dear to India. In fact, the lander is named after someone very important. Tribute to Vikram Sarabhai. The mission's name, Chandrayaan 3, translates from Sanskrit as mooncraft, aligning with its lunar purpose. The Pragyan rover, tasked with studying lunar soil, derives its name from Sanskrit, signifying wisdom. These names honor the heritage of Indian space exploration. But the lander bears a very important name, Vikram. The name Vikram is a tribute to Vikram Sarabhai, an influential figure in India's space program. Vikram Sarabhai was a visionary Indian physicist and industrialist who had a profound impact on the fields of space research and nuclear power in India. Sarabhai was born into an industrialist family in Ahmedabad in 1919. He began his education at Gujarat College, Ahmedabad, and later pursued natural sciences at the University of Cambridge in England, earning his tripos in 1940. World War II brought him back to India, where he conducted research on cosmic rays at the Indian Institute of Science, Bangalore. In 1945, he returned to Cambridge to complete his doctorate, authoring a thesis titled Cosmic Ray Investigations in Tropical Latitudes in 1947. Upon his return to India, he founded the Physical Research Laboratory in Ahmedabad. Sarabhai's interests spanned a wide range. In addition to his scientific endeavors, he actively engaged in industry, business, and development issues. He founded the Ahmedabad Textile Industries Research Association in 1947 and was involved until 1956. Recognizing the need for professional management education in India, Sarabhai played a key role in establishing the Indian Institute of Management in Ahmedabad in 1962. In 1962, he established the Indian National Committee for Space Research, later renamed the Indian Space Research Organization.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का.
He also founded the Thumba Equatorial Rocket Launching Station in southern India. After the passing of physicist Homi Bhabha in 1966, Sarabhai assumed the role of chairman of the Atomic Energy Commission of India, continuing Bhabha's work in nuclear research and contributing significantly to the development of India's nuclear power plants. He laid the groundwork for indigenous nuclear technology for defense purposes. Sarabhai was an advocate for the use of science and technology, especially in the field of space. As catalysts for development, he initiated programs to extend education to remote villages using satellite communication and promoted the development of satellite-based remote sensing of natural resources. In recognition of his exceptional contributions, Sarabhai received two of India's highest honors, the Padma Bhushan in 1966, and the Padma Vibhushan posthumously in 1972. With such an important name behind the lander, the pressure was on to complete the mission. So what happened after the landing? Let's find out. The rover has been deployed. With a smooth lunar landing, the Chandrayaan 3 mission now focuses on the next phase, deploying the Pragyan rover. The plan was that the Pragyan would descend from the lander and roam the moon's surface for 2 Earth weeks. This agile rover is designed to capture images, delve into lunar geology, explore the moon's origins, and hunt for signs of water ice. This stage would begin mere hours after the landing. So, shortly after the landing, Pragyan emerged from Vikram, marking a successful transition following the lunar touchdown. ISRO shared 2 revealing videos of Pragyan's debut on the lunar surface. The first displays the deployment of the ramp, a crucial step in readying the rover for its lunar journey. This ramp, with 2 segments, will enable the rover's smooth descent. The second video, a 30-second clip, shows the rover smoothly rolling out from the lander just hours after landing, captured by the lander's camera. The videos also highlight the unfurling of the rover's solar panel, providing it with power. These intricate deployment mechanisms, totaling 26 for the Chandrayaan 3 mission, were developed at UR Rao Satellite Center in Bengaluru. In further updates, ISRO reported that Pragyan has successfully traversed a distance of approximately 8 meters, and its payloads have been activated. The rover's movements have been in accordance with the planned trajectory. The rover on Chandrayaan 3 comes equipped with 2 key payloads, the laser-induced breakdown spectroscope, or LIBS, and the alpha particle X-ray spectrometer, or APXS, both of which are now active. These payloads serve a crucial purpose, enabling the determination of the elemental composition near the landing site. The mission, which includes the lander and rover, is planned to operate for 1 lunar day, equivalent to 14 Earth days.
TPV-based solid propellant, 204.5 tons.
In addition to the rover's payloads, the lander also carries 4 scientific instruments. These instruments focus on investigating thermal conductivity, temperature, seismic activity, and other lunar surface characteristics. At the time, 3 of these instruments, named ILSA, Rambha, and Chasti, were operational. ISRO reported that all payloads on the propulsion module, lander module, and rover were performing nominally, showing that the mission was proceeding as expected. ISRO even released a photo of Chandrayaan 2 spotting the Vikram lander, but they deleted it from Twitter later. Then there was an exciting development on the 26th of August, 3 days after the landing. Prime Minister Narendra Modi declared that the Vikram lander's lunar touchdown site is to be named the Shiv Shakti Point. Furthermore, August 23rd, the day when Chandrayaan 3's mission succeeded, is now recognized as National Space Day in India. And a few hours after this announcement, ISRO shared a video of the Pragyan rover navigating the lunar surface around the Shiv Shakti Point, marking another milestone in India's lunar exploration. Interestingly, the rover's rear wheels have been specially designed to leave impressions of both ISRO's logo and the Indian national emblem. Now, the reason why this is important is because driving on the moon is no easy feat. The challenges of the moon. Roving on the moon is like driving on ice from the worst ice storm ever, according to Jeff Vogt, a vehicle dynamics expert at General Motors. The lunar rover for this mission, named Pragyan, weighs 60 pounds and relies on solar power. It conducts on-site analyses, relaying data to the lander, which sends it back to mission control on Earth. It moves on 6 wheels, but it's extremely slow. It travels at a rate of 1 cm per second. Lunar rovers have to deal with a lot of things, like darkness, extreme cold, radiation, and tricky terrains. Certain parts of the moon, like the poles, are in a constant state of light or dark. Areas like mountain peaks are always sunlit, while deep craters remain shrouded in darkness, sometimes permanently. These are called permanently shadowed regions, or PSRs. These exist because of how low the sun can get above the horizon. As such, these light and shadow conditions create unique challenges. For lunar rovers, darkness is a real headache. They rely on solar panels for power, and without sunlight, they can't move, use their instruments, turn on lights, or communicate with Earth. Ensuring solar panels reach the moon intact is tough because they're fragile, and rocket launches are turbulent. Rough landings can also damage the panels. To survive the darkness, Rovers must find sunny spots to recharge their batteries. This ensures they can run their heaters. Additionally, they can recharge using a lunar lander nearby, acting as a home base for the rovers during their lunar missions. The rover might use special software to locate the lander. When it's nearby, the rover can recharge itself using wireless technology. Ybotic, a company selected by NASA, will provide this wireless charging tech for upcoming lunar missions. The Pragyan rover's expected runtime is 1 lunar day, roughly equal to 14 Earth days. It wasn't built to endure the freezing lunar nights. Still, it has a clever solar-powered system that could extend its service longer than expected. Talking about the lunar night, the moon has extreme temperature swings. Days can sizzle at about 127 degrees Celsius, while nights plunge to a bone-chilling 173 degrees Celsius. Some craters are even colder. In the moon's Hermit crater, instruments aboard NASA's Lunar Reconnaissance Orbiter recorded a staggering 250 degrees Celsius. To keep warm and fend off the cold, rovers get a coat of gold paint. This gold layer stops heat from escaping through radiation, much like how a thermos bottle keeps your coffee hot.
मत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के.
Rovers can also use special insulation called aerogel to ward off temperature shifts. This insulation is mostly air, nearly 99.8%. But why air? Because it's a terrific insulator and super lightweight, perfect for space missions. Rovers also come equipped with temperature control systems, including heaters. A built-in thermostat regulates these heaters, turning them on and off as needed. To release excess heat, there's a system with a pump and tubes that works like a car's air conditioning. But temperatures are not the only thing to worry about. In space, high-energy particles called cosmic radiation, or cosmic rays, fly around. These particles pose risks to both humans and equipment in space. The magnetic field and the atmosphere on Earth guard us against harmful space particles. But the Moon, unlike Earth, lacks this protective cloak. No atmosphere, no strong magnetic shield. It's exposed. On the Moon, astronauts face radiation levels 200 to 1,000 times Earth's dose, a whopping 2.5 times more than the International Space Station. This excessive radiation threatens astronauts with cancer and other illnesses, and it doesn't spare lunar rovers either. Radiation can ruin rover electronics, causing failures. Computer chips can fry, and memories can vanish. Radiation can make wiring insulation brittle, leading to wire breaks and system short circuits. Rovers must have special shielded wires to survive. Navigating the Moon isn't a cakewalk either. From afar, the lunar surface might seem flat, but it's deceiving. Some parts are smooth, while others are steep and rough, filled with craters. Rovers face the challenge of climbing and avoiding getting stuck while exploring, and when it comes to their wheels, they need to be robust. The Moon's terrain includes sharp rocks, and even its fine, dusty soil has tiny, jagged rock fragments. These are microscopic in size. Rover wheels require sturdy treads for traction, since lunar soil is slippery. To ensure rover capabilities on the Moon, engineers test them on simulated lunar surfaces. Engineers conduct these tests on simulated lunar surfaces, using mineral-based simulants that mimic the texture of actual lunar soil. One significant challenge is designing rover wheels capable of navigating steep crater walls. Engineers have experimented with various wheel designs, from deep grooves to spikes, and even mesh wheels. Regardless of the design, rover operators are trained to avoid potential sticking points. For navigation, the Pragyan rover relies on a stereoscopic camera-based 3D vision system, equipped with two 1-megapixel monochromatic nav cams at its front. These cameras provide the ground control team with a 3D perspective of the terrain and assist in path planning by generating digital elevation models. IIT Kanpur has played a role in developing light-based map generation and motion planning for the rover. The rover's design also encompasses control and motor dynamics. It features a rocker-bogie suspension system and 6 wheels, each driven by independent brushless DC electric motors. Steering is achieved through differential wheel speed or skid steering. No doubt these design decisions have helped the rover to navigate the terrain, but this regolith is not only slippery to drive on, but kicks up an abundance of dust that poses issues. Moon dust, unlike Earth, remains sharp because the Moon lacks water and air, which typically smooth rocks through weathering and erosion processes. Furthermore, moon dust, with its sharp edges, carries a static charge, causing it to cling to surfaces. This dust can quickly accumulate on a rover's cameras, obscuring the operator's view. Impaired visibility can lead to collisions with rocks or falls into craters. Additionally, dust infiltration into mechanical parts can disrupt their functionality. Efforts to combat lunar dust challenges have drawn inspiration from technology developed for astronaut spacesuits. This includes strategies to create electrical charges that repel dust and applying dust-resistant coatings. The objective of Chandrayaan 3. Now we know that the objective of Chandrayaan 3 is to find water. But formally speaking, here are the objectives that the ISRO has laid out for the mission. These are to demonstrate a safe and soft landing on the lunar surface, showcase rover mobility on the moon, and conduct on-site scientific experiments. To fulfill these objectives, advanced technologies are integrated into the mission. The propulsion module includes the shape payload for spectral and polarimetric measurements of Earth from lunar orbit. The lander has been equipped with a range of payloads too. Chandra's Surface Thermophysical Experiment, CHISTE, measures thermal conductivity and temperature. The Instrument for Lunar Seismic Activity assesses lunar seismic activity. And Langmuir probe estimates plasma density variations. A passive lunar retroreflector array from NASA aids lunar laser ranging studies. With so much expensive equipment, why would the scientists at ISRO risk landing their craft on the South Pole? Their choice to land at the South Pole wasn't just a random decision. This landing and its location are very important for one reason. Why is this landing so important? It's because there might be water there. The lunar South Pole is a prime landing site due to its known water ice deposits. Water isn't just vital for life, it has multiple applications like equipment cooling and potential rocket fuel. And the best thing about this is that the space shuttle uses this same kind of rocket fuel. Discovering substantial water ice on the moon is a huge deal for future space missions. If we find abundant water ice, it could enable sustainable lunar bases. This water is a valuable resource, capable of being used for extracting oxygen and rocket fuel. Speaking of rocket fuel, water is a superb candidate.
Namaskar. Sir, we have achieved.
Imagine launching missions to Mars, staged from the moon with its readily available water-derived rocket fuel. For the sustainability of space missions and the potential lunar bases, on-site water extraction proves vital. It's indispensable for drinking, cooling equipment, and as a source of breathable air. Water on the moon isn't only practical, it's scientifically valuable. It acts as a historical record, detailing lunar geological activities, like past volcanic eruptions. It's a repository for the history of asteroid impacts. While water has been scattered across the lunar surface, the majority of water ice gathers at the poles. These regions are special because the sun's light only shines on the elevated peaks there, due to the moon's unique tilt, leaving low-lying areas in perpetual shadow. In these permanent shadow regions, water molecules promptly freeze upon arrival and remain trapped in the freezing cold. Over time, this trapped water gathers, mingling with lunar soil. So in the end, you have large reservoirs of water and soil at the moon's south pole. For further exploration, the Pragyan rover carries two essential instruments: the laser-induced breakdown spectroscope, LIBS, and the alpha particle X-ray spectrometer, APXS. LIBS serves to analyze the lunar surface's elemental and mineral composition, advancing our lunar understanding. The APXS is tasked with determining the elemental makeup of the moon's soil and rocks near the landing site. So did the rover find water on the moon? What Pragyan found? Sadly, as of this video, the rover has not found any water or hydrogen on the surface of the moon. But it did find something else that shocked scientists: sulfur. Pragyan has identified the presence of sulfur at the moon's south pole. Sulfur is relatively scarce on the moon, and is especially intriguing because it may indicate the existence of water ice. The LIBS instrument has conducted groundbreaking in situ analyses, a first for the lunar surface. These on-site measurements have unequivocally verified the presence of sulfur, something which couldn't have been done with orbital instruments. LIBS uses an intense laser to examine materials. When this laser is directed at a material, like lunar rock or soil, it generates a highly localized superhot plasma. The emitted plasma light is then analyzed, revealing the material's elemental composition. This is because every element emits a unique set of wavelengths when it's in the form of plasma, so we can find out what it is we're looking at. But it wasn't just sulfur that it found. Preliminary findings have unveiled the presence of aluminum, calcium, iron, chromium, and titanium on the lunar surface. Further analysis has confirmed the existence of manganese, silicon, and oxygen. The presence of oxygen is a significant discovery, with potential implications for future lunar exploration. The rover then continued to search for hydrogen until it was put to sleep. Is the rover dead? On September 2nd, 2023, ISRO reported that Chandrayaan 3's rover Pragyan successfully completed its tasks and has been safely parked in sleep mode. The rover's assignments are done. It's now in sleep mode with the APXS and LIBS payload switched off. Data collected by these instruments was transmitted to Earth through the lander. With a fully charged battery, the receiver being left on, and the solar panel adjusted to catch the next sunrise, Pragyan rests. The next chance it'll get to awaken would be September 22nd, when it will conduct more missions. But if it didn't wake up, it would be considered as India's lunar ambassador, according to the ISRO. ISRO Chairman S. Somanath shared earlier that day that the rover, along with the lander, is operational and had even moved a total of 100 meters before finally resting. Originally, the rover was planned to cover 350 meters, but it has only covered 105 meters so far due to uncertain reasons. ISRO put the rover into sleep mode because it needs to endure the lunar night when sunlight isn't available. During this time, a small solar panel on the rover will generate power to charge the battery for the next 14 days until the return of sunlight. It cannot be overstated how cold it gets on a lunar night. Once the sun sets, temperatures plunge to a bone-chilling 200 degrees Celsius. Surviving such a cold is no guarantee for batteries and electronics, but ISRO, after rigorous testing, expressed confidence in the rover and lander's ability to endure these harsh conditions. But while the rover was resting, the Vikram lander performed an experiment. It conducted in situ experiments with Chasti, Rambha LP, and ILSA payloads. Its data was transmitted to Earth, and then the payloads were deactivated, but the lander's receivers remained active. Then on September 3rd, the Vikram lander performed a brief hop, firing its engines and touching down about 30-40 centimeters away. But after this hop, it was time for the lander to rest too. Vikram was put into sleep mode on the 4th of September. As the lunar night enveloped the landing site, the Vikram lander entered sleep mode. The lander and rover both had the potential to reawaken after the sun rose on September 22nd, but this never happened. Following a lengthy and frigid 14-day lunar night, ISRO geared up to reawaken the lander and rover modules of the Chandrayaan 3 mission. On September 22nd, sunlight returned to the Shiv Shakti point in the Moon's south polar region, where the modules were positioned, providing the essential warmth needed to reactivate Vikram and Pragyan's solar panels. ISRO's scientists worked towards the successful recovery of these modules, despite the harsh cold. However, ISRO postponed the reactivation plans for Vikram and Pragyan to the next day, September 23rd.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
Nilesh Desai, director of the Space Application Center, explained that the initial plan was to reactivate the rover and lander on the evening of September 22nd. Due to unforeseen reasons, they postponed the operation to September 23rd. But they weren't able to reactivate the modules, even on the next day. ISRO confirmed its failure to acquire any signal from the Vikram lander. Nevertheless, their efforts persisted into the following day. Even then, no signal. ISRO attempted to re-establish contact with the lander and rover until the next lunar sunset. On September 30th, they remained hopeful that the rising sun at Shiv Shakti Point would reanimate the equipment. Whether or not ISRO will ever reconnect with Chandrayaan 3's instruments remains uncertain. Despite ongoing attempts to re-establish contact, no communication has been achieved as of this video. Reviving the lander and rover was meant to be an automatic process, initiated by solar charging during the lunar sunrise on September 22nd. Yet, no signals have been received. If the electronics endure the cold, there's a 50-50 chance of reawakening. However, the mission has already fulfilled its objectives, even without revival, according to Nilesh. If reactivated, the lander and rover would continue their scientific exploration of the lunar surface. However, the rover has remained inactive. Let us know in the comments if you think the rover will ever be revived. Or will it stay on the South Pole forever as a reminder of this glorious achievement? Be sure to leave a like and subscribe for more.